Hello friends, in the last session we discussed about the specific speed. The specific speed is decide the pump characteristics curve and types of the impellers. The characteristic curves of the pump, three types. One operating characteristic curve, main characteristics curve and constant efficiency curve. So now discuss about the operating characteristic curve. A graphical description of performance of pump showing the variation in head, brake horsepower, efficiency, net positive suction head required with respect to the discharge, okay, which is represented on the x-axis. This curve also called as operating characteristic curve or pump characteristic curve. Okay, this characteristic curve is developed with respect to constant speed. This curve will show that discharge versus your head, discharge versus your efficiency, discharge versus brake horsepower, and discharge versus net positive suction head. So this combination, all this curve is called your operating curve or performance characteristic curves of your centrifugal pump. This curve is drawn for a constant speed. Okay, rotational speed of your pump n, that should be constant. So in this condition, what happening about your discharge, or what happening about your head, what happening about your power, what happening about head, all these things will analysis. Okay, that is called your operating curve. So let us see one by one. So now case 1, that is a head and capacity. Capacity means that discharge head, how much pressure head will create so that water can lift to horizontal or vertically. Okay, now if you are assuming the pump is in horizontal, now this is your inlet. Okay, water is flowing or pumping in horizontal only. Okay, now water will come and flow in this horizontal direction only, so that there is no head is required. Okay, no head is required. Suppose this pump is turning from horizontal to vertical direction. If you are turning this pump, water is pumping in vertical direction. In this, if you increase in the head, if you are increasing the head, here head is 0. Okay, it is equal to your x-axis. If you are increasing head, okay, now what will happen? So this head will increase but discharge will reduce. Okay, head is increases but discharge will reduce. That is the graph here. See, head, that is low, very low, that is up to here. Suppose this is a 20. For 20 feet the discharge is 15. Okay, 15 GPM. And for the, suppose see, the discharge is reducing and head is increases. See this, suppose at this point the head is up to 80 meters and the discharge is only 3 GPM. Okay, so now it will say that the curve head is and discharge curve are falling curve. Okay, and this is also called a parabola in shape. So that is head drop for a given flow rate increases. So how much, what is the head here? That is how much water can pump will deliver for a given head. This will show that Q versus head will show that how much impeller or pump can draw the water and deliver to a for a given height. So this is also operating for a 0 head. Okay, so if you see this here, this point, even the impeller will rotate, start when you start the motor, the impeller will rotate. Okay, at initial period, at initial time, no discharge for a given head. Okay, even pump will rotate. So that is called your shut off head. That is called your 0 discharge. In this condition, 0 discharge. So this curve is called performance curve. Okay, next one, your efficiency and capacity, pump efficiency versus your discharge. Okay, the efficiency is the ratio of your output at a fluid for a given pump to the what is the power is supplied for the electric motor to rotate this impeller. So that is ratio. So this also for a given, as I told you, when the pump will rotate, there is no discharge. Okay, you know the pump efficiency is output by input. So if your discharge is output 0, then what is the efficiency? Efficiency also be 0. That means efficiency of pump at start, that is 0. So that curve will start at 0 and it will go on increases. Okay, and will reach a certain stage that it peak. After that, if you increase the speed of this pump, then the discharge also increases but efficiency is reduced. That is called your efficiency curve. For every given pump, there is only one best efficiency point. Okay, that is a best efficiency point, the flow at which the pump operates at highest or optimum efficiency for a given impeller. That is called your best efficiency. This efficiency varies with your pump manufacturer and model types. If you are using different types, every pump have their own efficiency curves. Next one is the brake horsepower. Okay, power is nothing but to rotate the impeller. Okay, required to the motor to drive the impeller so that water can pump for a given height. Okay, for discharging the water. That is called a power, brake horsepower. So as the flow rate, okay, as the flow rate increases, the power consumption of the motor also increases. Very simple. Okay, if you increase in discharge, the flow rate increases, the power consumption of this impeller will also increases, but not that much drastic steep. This will increase very slowly. The brake horsepower reaches the peak at a higher rate of discharge than there where which produce the maximum efficiency. What does it mean? Even though the brake horsepower is increases, okay, after the peak efficiency, but here also the maximum discharge, okay, the maximum discharge, but efficiency of the pump will reduce. That is now, so that we will take the best efficiency point, okay, where the efficiency and head curve, this is a head curve, falling curve, so where this both will join or both will meet, this is the point, both are meeting, this is called your best efficiency point. So at this condition the head is 60 meters, okay, where the head and efficiency curves will join. Okay, so this is the most important point, so that this is the operating point of your pump. And next one, last one is your net positive suction head required. We know what is the required, where is the power available at the impeller so that water can comes into the impeller. So that is the net positive suction head required. Define the amount of energy required to move the water into the impeller. So that is your energy or head availability your impeller. So this required is function of pump speed, impeller shape, and fluid properties and discharge rate. This depends on your pump factors. For cavitation free, we always need the available net positive suction head available should be more than required. Should be more. This is the most important question. So, okay. So this is simple characteristics curves of your centrifugal pump. Now next one is your main characteristics curve of your centrifugal pump. This is the x-axis, N, speed of the pump. In y-axis, we will take the power and head and discharge. So we will draw the relation between only power, discharge and head. So in this condition where Q directly proportional to N, this comes to a straight line. Next one is your the head is proportional to the square of your pump speed. The head directly proportional to your square of your pump. So that is curve we call it parabola. So this is curve. To obtain this curve of the head or manometric head versus speed, the discharge is kept constant. And last one is your power, brake horsepower. So this power is cube of your N or speed. So this is called your cubic curve. This curve will obtain when you are keeping constant, that is discharge and head. So this is the curve. Okay, don't confuse between your main operating curve and characteristics curve. It represents discharge versus your head efficiency and brake horsepower. Okay, this is in x-axis. Now the speed is on x-axis. The speed x-axis and remaining parameters are on y-axis. And last one is your constant efficiency or muscle curve. So this curve will constant efficiency curve will obtain for combination of two graphs, head and discharge. This is one curve. Okay, again your efficiency versus discharge. This combination of this both curve give the constant efficiency curve. Okay, that is important. So constant efficiency, it tells us that call your iso efficiency curves. So this is the iso efficiency curves of the pump. Thank you.